Right, welcome back to Polybridge. This time I thought I'd do something a little bit different and actually try to work out if this game is realistic. Could it be used in real engineering? So yeah, I'm trying to be a little bit more clever than my previous videos, but I've already failed that test in that I recorded this whole video already with the microphone off. So this is the second time I'm going through this, which hopefully means I talk a bit less bollocks and a bit more engineering stuff. Oh, I'm such an idiot. Right, so essentially what I want to try and work out is how the game kind of works, how it's programmed, just by doing a few simple tests. So how I'm going to start is by doing a simple piece of wood, and then I'm going to put various things on top because the weight of this will go through this one. So if I were to do that, so we're essentially just looking at this one piece down here, and the 2% is the amount of stress going through this piece, because this one there's no weight on top, so we're all about this one. So as a simple test, we're going to put steel in place of the wood and see if the percentage goes up. So no, we're just on 2%, which is quite unusual because you would expect steel to weigh more than wood. So we'll quickly just go through all of these. Hydraulics 2%. Rope and cable are going to be a bit hard to test in this situation, but I'll do spring. 2%. So this is kind of making me think the weight of the material doesn't change depending on what it is. So if we were to do 2 pieces, so that goes up to 4%. So if we swap that with steel, exactly the same situation, we've just swapped the thing with steel, so we're on 4% again. Yeah, and springs, hydraulics, exactly the same. So essentially, doesn't matter what one you use, the weight is identical. So I think the next test then is to try and work out if the length of the material affects its weight. So as we know these are all the same, the simplest thing to do is use steel because it's the longest. And we'll just do one piece to get our first reading. It's around 2%. So you'd expect if I made this smaller, if the weight of the beam is taken into account in the calculations, that the stress going through here should be half because it's half the length. So we should be on about 1%. We're still on 2%, so let's not rule it out completely, but we'll make it a lot longer. So this should be over 2% if the length of the material is taken into account. And it's still 2%. So I think from that we can safely say the length of the material does not affect the weight. However, I've only tested these ones. We've got a line here where we've got the roads on this side. So let's test a piece of road. So just single length. If these were any of these materials, we'd be looking at 2%. And straight away you're up to 7%. So that would suggest that road does actually have a weight. So let's just try the reinforced road. So we were on 7. Now we're on 9. So reinforced road definitely weighs more than standard road. So if we were now to test the length as we did before. So we've got a normal piece of road, we're on 7%. So let's bring this right down. So if this was one of these materials, the stress through here would still be 7%. But now we're down to 6%. So, road, let's just see if it's the same with reinforced road. So reinforced road, I think it was 9. So we're on 9% when we're that long. If we do a very short piece, we're down to 6%. Wow, that's quite a big difference. So interestingly, road then, both types of road, the weight is dependent on the length. Okay, so let's now test whether a single piece, 7%, let's see if we were to make that 2 pieces, whether it's still 7%, which would suggest the weight of the road is only dependent on the total length, or whether putting this extra joint in, that ups the percentage, so therefore the joints actually weigh something. So yeah, we've gone up from 7% to 11%. So that means this joint actually weighs something as well as the length. So hopefully you're following, but essentially what we've learned is for road and reinforced road, the joints weigh something, but also the length of each piece affects the weight as well. So we've got just 2 pieces here. Let's make one really long, one really short, and then the weight should have gone up because there's more road. So 12, and when it was short, we're on 11. So it's definitely gone up. So a long length of road weighs more than a short length of road. And just to double check, we'll do the same test for steel. So we're on 4% there, and we'll make this really long. And we're still on 4%. So, I think when we're building our bridges, that's a really good test, because now we know the more pieces of road we put in, the heavier it's going to be. But the shorter the length of road, the better. Whereas with these materials, the number of pieces is key. So you want to use as small a number of pieces as possible to try and bring the weight down. If you remember back to my stone wall video where I did absolutely loads of mini triangles, that was because all these joints weigh something and the actual weight of the wood weighs nothing. Right, so if we go to this level where you've got a very short little span, I just wanted to prove that this game doesn't necessarily take everything into account that you'd want to in a real life situation. So in the real world, obviously if we were to put a beam along a length, it would have a weight, and therefore that weight would act along the beam in the form of gravity. So if it was just supported at either end, just like I've done here, this beam would curve. So it'd be very small, you wouldn't actually see it, but the weight in the middle would cause the beam to curve, so it'd be a nice little U shape. So therefore there's kind of force acting, stress acting along this beam. So just to double check that nothing's going on, if I do this, we're on 0%. So therefore the length of this beam affects nothing. And to prove that it's just the number of joints, we can do that. So nothing should move. It might bounce a little bit, but it should settle on a number. So 13%. And that is literally just the weight of this joint. So we can add more joints in, and that weight's just going to go up. So 14, that's on now. And then if we do loads and loads, it's just going to weigh even more. We're on 16%. So I think we've proven that it's got nothing to do with the amount or the length of the material you use. It's 100% down to the number of joints, which is highly unusual. And when you think about the real world, there's absolutely no way you could avoid not taking the weight of a beam into account, because essentially you're saying a beam that length, which when you think about just in terms of the amount of material, that's a lot of material. That weighs the same in this game as that, which is completely unrealistic, and therefore there's no way you could use this game in the real world of engineering in the terms of trying to create a model of something realistic. However, the game is very good at getting people involved in engineering, thinking about the efficiency of materials, bringing down cost, all that sort of stuff. So I'm not saying it's a bad game by any means, and there's no engineering skill required at all for this game, because that's completely not true. I'm just saying you could not use this game to model real life bridges. However, you probably could. If I go to the first level, there's my stupid bridge. Something that would be realistic is if you were to only use roads. So if I make a truss with these, so this should act full on mathematically how the real world works in terms of, oh shit, I forgot it's a road, so a car can't actually drive through it. So if I were to just quickly mirror that and plop it underneath, delete the ones on top, so a car can use it. But this is actually acting how a real world truss would act. Yeah, so essentially then we could use this program if we only use the roads to build a bridge. I wonder I just want to see if we could build with the reinforced ones and whether these have a better strength to weight ratio, because we actually care about that. With the roads, it's definitely stronger. So yeah, something we've just proven then is the reinforced roads have a better strength to weight ratio than the normal roads. So not only have we learnt they weigh more, but we know they're stronger, and they're stronger than their weight increase over the real road, if that makes sense. But we probably kind of already subconsciously knew that because we always used reinforced roads when our normal roads were breaking. So yeah, hope you guys found that interesting. I have actually learnt quite a lot that I didn't know previously, and that should help me trying to get up these leaderboards. So thanks guys, see you next time. If you like this sort of video, it's a bit different to my usual, let me know. Give me a like. If you don't subscribe, please subscribe, it would be very nice. But yeah, cheers, see you next time.